So let's go over that homework 8.2. Arithmetic sequences and arithmetic sums, which we didn't talk about, but I will talk about today. It was page, I think I said 598, 1 to 15 odd, and then I had, I think, 27 to 33 odd, 27 to 33 odd, and then I had for the sum section, which you could do by hand, but we're going to show you an equation that makes it much easier, 53 to 73 odd and 81. 53 to 73 odd, and then 81. So I can go over some of these questions. If you have a particular question, let me know. But let me first start by telling you what we learned about arithmetic sequences last time was an arithmetic sequence. Arithmetic means you add the same number every time. Every time. If you're not adding the same number every time, it is not an arithmetic sequence. And we had a couple formulas that we used for arithmetic sequences, right? We had our general formula. This is all review from last time. If you don't have those notes from last time, maybe you want to write these down. Formula was a sub n is, you have the starting number, a sub 1, some starting number, plus the common difference times n minus 1. So a sub 1 is the first number in the sequence, and this d here is the common difference. It's basically what you're adding each time. What are you adding each time? That's what d is. The number you're adding every time. And a1 is your starting place. So you're saying, well, I'm starting here and I'm adding a certain number n minus 1 times. And that's how we write our sequence. The general formula, this is our general formula. One of the four equations we're going to need to know how to do. So general formula. We also had a way to find the numbers, right? Finding terms. Find the sequence. We had a way to find the common difference. What we said was take two values in the sequence, subtract them, and then divide that by how far apart they are. So for example, if you know A15 is 7 and A21 is 19, you say the top numbers, right? These values are these top ones. The values, right? The values. The terms, right? The pieces, the values. And the bottom numbers are the place number. The place number. Place number, right? The place value. Place number. And so we would say, okay, other way around. 19 minus 7 over 21 minus 15. Let's see, 19 minus 7 is, that would be 12 divided by 21 minus 15 is going to be what? Let's see, 21 minus 15, my calculators were invented, right everyone? 6. So the common difference there, the common number is going to be 2. That means we are adding 2 every time in this example. Right? So you have the top numbers, the values, divided by the place values, how far apart they are. We started with the 15th, we got to the 21st, separate those numbers, find the distance. So that was a useful equation. We had this equation here. And then we had a way to find A1. A1 was we take some value subtracting d times n minus 1. This was to find the first number. And so these three equations form the kind of foundation that we can use to solve these kinds of arithmetic sequences. These equations solve the foundation, provide the foundation where we can solve the sequence. We can get an equation for the sequence using the general formulas, or equation for the sequence, and we can find any value in the numbers. We can find the common difference, and we can find the first term. And then from those, we can use that to write equations and find the whole sequence pattern. So we need this first term, and you need the common difference. These are the two key pieces. These two, the D and the A1, are the two key pieces we need to write our equation. And we can use those, again, we talked about this last week, we can find those terms using these formulas. This is like, I don't know, clever ways, little tricky ways. Or we can just do it the long way, right? If you know from 15 to 21, it goes from 7 to 19, you can just count it out. All right, let's see, what if I add 1? No, that's not 2, 3. What if I write? You can just figure it out the long way. And if you want to find A1 from this, well, if I know the difference is 2, if I start from 7, if I go back, if I subtract 2 15 times, well, 14 times, I'm going to get to A1. So I could do it the long way. There's nothing like, stopping you. You can just find this using brute force. That's the beautiful thing about these arithmetic sequences, right? They all have this pattern. But we have these clever ways to figure out how to do it a little easier. And that's what I wanted you to do for the assignment for 4.2. So, going over this assignment, were there any particular questions in the list here that people had, or should I just do one from kind of every section? Would that be helpful? Let me know in the chat. Informal poll. Are there particular questions? Or would people just kind of like to see one from every section, one from each section? Edward wants one from every section. Do we agree, everybody? Is that helpful? One from each of these pieces? All right. Sounds great. Well, I'll pick a number from each section and we'll go over those together. So let's look at the first section. It just asks you basically yes or no and what the common difference is. So let's look at number, I don't know, 5. 5 is pretty good. Let's look at number 5. Is it arithmetic? And if so, find the common difference. So number 5 says I have negative 24, negative 24, negative 16, negative 8, 0, 8, and that's my pattern. So is this sequence arithmetic? To check, we just see what we're changing every time. Are we adding the same thing every time? We're subtracting the same thing every time? Seems to be, right? Yeah. This is plus 8. This is plus 8. This is plus 8. And this is plus 8. So that would be a yes. And the common difference is positive 8. Right? And that's all I wanted from these questions. In the first section, figure out the common difference. Figure out how to do that. But what about a trickier one, like number 3? Oh, it's got fractions. Mister, it's got fractions. I don't like fractions. Well, you're in pre-calculus. So I don't know what to tell you, everybody. Deal with it. That's my answer for you. Deal with it. Number 3. How do we deal with the fractions? Let me show you this. 3, and then 5 halves, and then we have 2, and then we have 3 halves, and then we have 1, dot, dot, dot. How can we tell, I mean, maybe if you're clever you can see, but how can we tell for sure if this is an arithmetic sequence, what can we test? What can we do? Well, to test, we can like test it. Test points. We can take two values next to each other and subtract them. So I can take 5 over 2, and we subtract it backwards, right? We take this first one minus the second one. 5 over 2 minus 3, and that'll get us the difference of those two pieces next to each other. And then we do it again, and we can do it again, and just see if they're all the same. Do that subtraction over and over. 5 halves minus 3. Subtracting fractions, mister. Yeah, well, too bad. Common denominators. That 3 is over 1. Multiply by 2, multiply by 2. 5 over 2 minus 6 over 2 is negative half. Look, that wasn't so bad. That wasn't so bad, everybody. I feel like I'm talking to my son right now, little Rowan. He's 3 weeks, almost 3 months old, everyone. It's not so bad. Oh, it's okay, little Rowan. It's okay, kids. You can do fractions. Look, you're all powerful 11th and 12th graders. You know so many things. Way more than he does. Please, come on. So that was it for the first two. Let's test another one. Let's do 2 minus 5 halves. See if it works the second one. And if they're the same, then we know that it's probably arithmetic. Testing the next one. It says test points, by the way. Test points. Take this one minus that one. Take the 2 minus 5 halves. Again, 2 over 1. Multiply by 2. Multiply by 2. We have 4 over 2 minus 5 over 2, which is, again, negative half. Here we go. That means our common difference for everything is negative half. Yes, D is negative half. So we tested it, we checked it out, and we figured it out. If you're clever, you may have noticed you could change this 3 into a 6 over 2, and this 2 into a 4 over 2, and this 1 into a 2 over 2. And you see we have 6 over 2, 5 over 2, 4 over 2, 3 over 2, 2 over 2. Next would be 1 over 2, and then 0, then negative 1 half, negative 1, negative 1, negative 3 over 2, right? All the rest. So sometimes it's helpful if you rearrange the numbers here. You can imagine them as these fractions. And then you see, oh yeah, I'm just minusing 1 every time, minusing a half every time. Very good, everybody. All right, so what else? That's that first section, just testing if they are arithmetic or not. Next section asks us to write the first 5 terms of the sequence. So let's look at maybe number 11. It says AN. It says write the first 5 terms. Write the first 5 terms. And test, is it arithmetic? Is it arithmetic? Number 11, write the first 5 terms, see if it's arithmetic. AN is 1 over n plus 1. So we're going to want n to be 1, 2, 3, 4, and 5. Oh, whoopsies, 5. And we are going to want to plug that in and get the numbers. So if I plug in a 1 here, it's 1 over, right? 1 over my n value here, this n value, becomes what I plug in. Right? So it's 1 plus 1, which is going to be 1 over 2. And then if I keep going, obviously it's going to be 2 plus 1, so that's 1 over 3. And this is going to be 1 over 4, and 1 over 5, and 1 over 6. Right? And it keeps going, keeps going, keeps going like that. So the question is this arithmetic? Well, we're adding 1 to the bottom each time. How can we check for sure? The way we check is take 2 values, subtract them from each other, and check. Check if they are the same every time you do the subtraction. So let's do the subtraction. We're testing. We're doing 1/3 minus 1/2. Oh my gosh. I have common denominators again. I'm going to do crisscross applesauce, right? 3 is here, this is there, and this is there. So I multiply this by 2 and by 2, multiply this by 3 and by 3. So I'm going to get 2 over 6 minus 3 over 6, which is negative 1 over 6. So that is my common difference for the first group, negative 1 over 6. What about the second group? Let's try it again. Let's see if they're the same. Maybe it's the same. 1 over 4. Always take your later one minus the earlier one. Later one minus the earlier one. 1 over 4 minus 1 over 3. Again, let's do some crisscrossing and common fractions. We've got times 3 times 3, and this is times 4 times 4. So we're going to get, let's see, 3 over 12 minus 4 over 12 gets me negative 1 over 12. Uh-oh. Those are not the same. The difference between this group here is negative 1 over 12. So these are not the same, so it is not arithmetic. And that's how we figure it out. We test the groups next to each other. If it's something we can't obviously see. If it's obvious, you don't need to test it. If it's obvious, just it's obvious. But if it's not obvious, we can figure it out by doing this subtraction test. Subtract each number after each other, see if it's the same. Questions about that? Jose, welcome. Alfredo, welcome. So that was number 11. That was that group. And that was that group up to 15. What did I say? Did I go up to 15? Then 27 to 33. All right, 27 to 33. Let's see about this one. It says something about a graphing calculator. Don't worry about that. We're just doing this all by hand. So we're going to take a look at that next section. Let's look at numbers 27 to 33. And let's look at number 27. For this, I want you to find an equation. Find, I should say, the general term. The general term is a sub n. So for these questions in this group, we are looking for the general equation, a sub n. Let me ask you, what two things do we need to know to get the equation of a sub n? What two things do we need? What do we need? Type in the chat, what do we need? To do this problem, let me do this in blue. What do we need to find a sub n? For a n. We need two things. To write the equation, we needed two things. What two things do we need? Someone put that in the chat. What two things do we need? Nobody knows. Look at the equation. There's two sort of like variables in that equation. We need those two things. To find the formula, to find the general equation, we need, I told you earlier, no one wants to be, what do they call it, academic risk taker? You all know it. You all have the equations. What are the two things I need for a sub n to find the general equation? Let's look at our formula. Let's look at our formula, everybody. Where's a sub n? Here we go. Here's our equation. Here's our general equation. A sub n equals this formula. So to write this equation, what two pieces do I need, everybody? What two pieces? Yes, A1 specifically. I need the first number And this D, yes, very good, thank you, Ricardo. A1, I need my first term. I need to know where I start, and I need to know what my common difference is. I need A1, and I need my common difference. I cannot write the equation without those two pieces of information. Thankfully, for number 27, they tell us. Number 27 says A1 is 5, and the common difference is 6. So they tell us directly, which is very, very nice. This number, AF5, is the starting number, start number. And this 6 here is the number we add every time. Add every time. So we have those two values. And so to write our equation, this is going to be very easy. AN equals, I know it's A1 plus, A1 plus D times N minus 1 is my formula. So I have my A1, I have my D, I'm going to plug them in. AN is 5 plus 6 times N minus 1. N always stays. N is the number that we're looking at, right? If we want to find the 5th term, N would be 5. If we want to find the millionth term, N would be a million. So N is the number that we keep that as our variable. But the 5, the A1, and the D, the 6, those go into our equation. And that's our answer. Oh, that was so nice of them. They gave it to us. Look, they gave us the two numbers we needed. How nice. Are they always that nice? No, they are not always that nice. Let me do one more here. Let's look at number 31. Again, find the general equation AN. They tell us, in number 31, they tell us that A sub 8, eighth number, is 26. And they tell us that the, where'd it go? 12th number is 42. So again, I need A1 and my common difference. I don't have A1, I don't have my common difference. I have two random numbers on the sequence. How do I find where the sequence begins and what the sequence common adding is? Easiest to find first is our common difference, right? We talked about that before. We have two other formulas we use, right? Two other of these equations. Write these equations somewhere very prominent that you can find them again. We will use these constantly for this unit. Your general formula for arithmetic sequences, I should say arithmetic. And then finding these two terms D and A1, right? So for the common difference, remember we took the two numbers and we subtracted the numbers minus the distance between them. And we divided that. So for the common difference, we have these two numbers here. So we're going to take our D and we're going to say it's going to be 42 minus 26. 42 minus 26 over the distance between them, which is 12 minus 8. You always go backwards. 12 minus 8. Always go backwards. From this one to that one. So this is where we break out our calculator. 42 minus 26 is 16. And 12 minus 8 is 4. 16 divided by 4 is 4. So that's our common difference. That's the common difference of this equation. So I know that every time I'm adding a number to the sequence here, I'm adding 4 every time. Every time I'm adding a number, I'm adding 4. So that's my common difference. Great. D, check. Got it. Still need A1. Still need A1. Well, we have another equation for A1 up here. It's A1 is some starting number minus D times n minus 1. Minus here, right? We're subtracting, we're going backwards. So I can use that formula for A1. A1, I know it equals A some number minus D times n minus 1. But if you don't remember this formula, if you do not recall this formula, there's a brute force way you could do this. If I know that the number here is 8, I can just take the 26 minus 4 a bunch of times, a bunch of times, till I get to A1. Let's see, 26 minus 4, that'd be 22. That'd be A7 is 22. And then minus 4 again is 18. That'd be A6. And then further, right? You can keep going. You got calculators? Can do the work for you. Minus 4, minus 4, minus 4, minus 4, minus 4. Count the number of times, right? 8, 7, 6, 5, 4, 3, 2, 1. Right? We can do that. If you don't remember this formula, if you don't want to hassle with it, just do that. It's a pattern. We have patterns, right? This is AP counting, everyone. AP counting, like I said. But we can use this equation instead. Let me show you how to use this equation. I'm going to use this one for this equation here. So I'm going to use the 26 and the 8, right? The 26 is my number. That's the number I'm using. That's my starting number, 26. I want to go backwards 4 times 8 times minus 1. Because I'm doing it, I'm starting on my 8th number. So the 26 was the 8th number. So I'm starting, AN is my starting number, the 26, minus my difference here is the 4. I do it 8 minus 1 times. I do it 7 times to get back down to 1. So we can just plug this in the calculator. 26 minus 4 times 7. That's 26 minus 28. That's going to be negative 2. And that's A sub 1. So instead of doing it over and over, I could just shorthand. That's a 7 there, by the way. That's a 7. 26 minus 28 gets me back down to A1, which is negative 2. So I've got my D, I've got A1, check, check. Now let's write our equation. A sub n is A1, negative 2, plus 4 times n minus 1. There's your equation. You got the D value, you got the A1 value, you found your formula.